So here's how you do Professor Ozbay's Fundamentals of Aero class, Project 1. So you're gonna drag the fluid flow fluent into the project schematic, and then we're gonna change the analysis type to 2D, and then we're gonna right click the geometry, and then new design model geometry. Take a second for that to load up. All right. So with this, we're gonna go to units and then go to inches, and then I'm gonna center myself on the XY plane, um, and then we can start sketching. Start with 3 lines, horizontal lines, and then we'll dimension these, and then we'll make those 24 inches, and then 12 inches, and then 42 inches. So just kind of center myself again here. And then we're gonna draw 4 vertical lines now. They can just kind of be anywhere. We're gonna put constraints on them to fix where they are. So, yep. And then we will dimension these as well. But just the first 3. So we're gonna make those 22 inches, and then this will be 6, and this will also be 6. And then we're going to go to constraints, and then put a midpoint constraint on this one, put it right there, and then a midpoint constraint on this one, put it there, this one, there, and the last one goes on the end. And then we're going to draw connecting lines now to make the outside of the wind tunnel. And then a rectangle for the settling chamber here. I'm going to make sure that if you see that little pink line, that means it's in line with the other point. So the top is going to be the right height as this height. So then all I have to do is dimension the length down here. And that length is going to be 15 inches. And so now we also need to dimension this diffuser half angle here, which A8, that is going to be 183 inches. Since my diffuser half angle is 3 inches, that looks right. The angle might get a little weird, so you may have to subtract it from 180, or you might have to just put 3 degrees in there. It's gonna be maybe different depending on the way that you click it. But yeah, so now we're going to put the left part at the origin. So I'll just go to constraints again, do midpoint constraint, put this left wall at the origin. So now that is looking good. So we'll just go through and select all of these unnecessary lines and delete them. Be careful here to not delete any outer lines. All right, perfect. And then that should be good. Oh wait. Yeah, we're gonna go to concept up at the top real quick, and then do surfaces from sketches now. And then click our sketch, which is here, and then click generate. And then click apply. Yeah, yeah, so it should be generated now. And then now we're gonna go back to the workbench and make sure this geometry is updated. So just right click it, click update, and now we can go ahead and mesh it. So double click mesh, and that should take a minute. All right, here we go. It's loading in. And actually we can close this design modeler as well. Okay. All right, perfect. So that should be good. Now we're going to right click this mesh and then insert a method. And for the geometry, we're going to select the wind tunnel. And then the method will do triangles. And then go back to the mesh. And then we'll change the element size to be 0.01 meters. Um, so yeah, and then we will click generate. Okay, so we got a mesh generated now. So then we're gonna select, control click all of the outer walls, and then press N and name this wall. And then we will do the inlet in a similar way. Inlet, and then the outlet. All right, so that should be good for the mesh. Now we'll right click this and click update. Make sure it's all updated before we move to the next step. So now we can close that window. And now we're gonna double click on setup. Wait for this to load. And then we'll go to double precision and we'll make 2 solver processes. So that'll take a minute to load, but all right. So now we'll go to, it's under models. Yeah, models, and then energy, we'll click on, and then viscous, we need to edit, and change this to laminar. And then for the boundary conditions, we're going to go to the inlet, and we're going to change this velocity magnitude to the inlet velocity, which for me is 2.614 meters per second. And you just get that by taking the velocity, using conservation of mass between the inner test section and the inlet, and then you'll get the velocity at the inlet. So we'll apply that. Okay. Let me just double check that is applied. Yep. Okay. And then we'll go to initialization right here. Double click it and then click initialize. All right, and then run calculation, double click, and then we'll just do calculate. Oh, sorry. Number of iterations we got to change to 150. And then now we'll click calculate. This should take a little bit longer. There we go. Okay, so that's complete. And if you want to make the contour plots, you just go to graphics and then contours. Double click that, and then you can change um, these to whatever you need. Pressure, you can change it to dynamic pressure, or you can change it to velocity, and then just do that one first. Save and display. So here you can see the velocity contour plot. And again, like static pressure, if we want to show that, we can do it there. And it'll give you some magnitudes over here as well. And then for the center line plots, we can go to plots and then XY plot. And then we have to make a new surface. And we're going to go to line/rake. And the new surface, we're just going to call it center line. And then we make the x1 equal to the length of the wind tunnel, which is going to be 2.3622 meters for my project. And then create that. So now we can select that and then get the values for the static pressure along that center line. And you can also write this to a file if you need to write the data to a file, but for now we'll just kind of look at it here, and you can see the plot, it plots pretty nicely. So yeah, that's how you do everything for the project one.